Hello, I am Muhammad Ali Haider, and today I will do a presentation on the state design pattern. So what problem is this state design pattern addressing? So the state design pattern addresses the problem of change that an object may encounter during runtime. So during runtime, we may want some objects to behave differently. This change in behavior is what we call a transition from one state to another. Usually we want an object to undergo transitioning when there are changes in its internal state. So in this case, when we say internal state, we are referring to kind of the variables and methods that can change the behavior of an object. And these, of course, are not visible to other objects as to why it's called, internal state. Another main problem that we are trying to solve or we're trying to address here is that state behavior should be defined independently. So this is kind of where the separation of concerns is about the principle. So adding new states should not really affect the behavior of existing states at all. And this also aids in scalability problems where, every time we want to add a new feature, for example, we may need to recompile or change a lot of the previous code or classes in the hierarchy. This is something that we don't want to do with the state design pattern. So that's another problem that we are also addressing here. And the way the state pattern goes to kind of solve these problems is we define separate state objects that kind of encapsulate a behavior for that specific state. So we have a state interface for performing these state behaviors, and then we'll have kind of these concrete states that we'll see later once I start talking about the structure, but these concrete states will kind of implement these interfaces. And these interfaces again will be, once they're implemented, will be kind of specific for each state. So now we want to talk about the motivation of the state design pattern. So when would we want to use this? So as previously mentioned, the main focus of this pattern is to kind of manage a change of state of an object kind of during runtime, during its lifetime. So knowing, so knowing this, the applicability of this pattern, kind of comes into play when we are using an object which can change states, during runtime, during its lifetime. So kind of a real world example of this pattern is, there are a lot we can use, but let's say we have a computer, right? So let's say we turn our computer off. So currently the state is off. We cannot really do anything else with it unless we turn it on. So once it is on, it has transitioned to a new state. So the new state is now on. So in this case, like we said, we went from the off state to the on state. The transition will be pressing the power button. This is what kind of triggers the transition in these two states. So another example of a state pattern is in the real world is like a traffic light, which is between three states: red, yellow, and green, and they each serve their own function, right? So red is stop, yellow is kind of like slow down, then green is go. There's also seasons as well. So fall, winter, spring, and summer. Just like the previous example, the transitioning here is time. That's kind of what triggers kind of the change between the seasons, just like how it triggers the change between the red light, the yellow light, and the green light. The structure of the design pattern kind of consists of three main parts. So first we have the context, which defines the object's current state. So in other words, it has references to concrete state object, or the concrete state object. This in turn could be used to define the current state. So the main function of this class is to kind of delegate these behaviors to different state objects. And next we have the state. So this is what defines the behavior related to a state. So it creates an interface to create an action that will later be implemented by a concrete state class. And this behavior is defined by the current context as well. And finally, we have the concrete state. So these are subclasses of the state class, and they, as previously mentioned, implement the interface provided by the state class. And these classes, they'll usually depict a specific state. So for instance, in our previously mentioned, real world example, a concrete state might be, either fall, winter, spring, or summer. These could all be concrete states, and each concrete state will have a behavior that has to do with the current state of the context. So here we have a kind of a visual of the default structure of a state pattern. So the methods used here can vary, the setup can vary, but here we just can see that the context class stores a reference of the current concrete state, which may be used to define the current state of the object. This mostly just defines an interface for the client to interact with as well, while the abstract state class is really just an interface for the concrete states to implement. So as we said earlier, it's defining a behavior which will be implemented in a concrete state, kind of more specifically, as in it will override that set state method. And then we have the concrete states, which are just implementing the interface from the state class, as we mentioned earlier. So here we kind of have a motivating example of like when we could use the state design pattern. Again, we're using kind of that example we talked about earlier of the seasons. So let's say we want to create an app that transitions through seasons starting with fall. So in this case, we're going to need a total of 4 concrete states, each with its own specific behavior. So we have the fall state, the winter state, the spring state, and the summer state. So here we have a visual of this seasonal app. So again, we have the context, which again, defining the object's current state, and it will also kind of act as an interface for the client. We have the season state class, which is our abstract state class. Again, this will have the kind of method that, or the interface that the concrete classes will implement, will override. And we have our 4 concrete state classes, the fall, winter, spring, and summer. And again, these just will implement the interface from the season state class. So this is kind of a breakdown of what the code will look like, and at the end we'll see kind of a demo of what the output is like. So again, we have the context class here, and as you can see, it kind of sets the current state, sets a reference to the current state, and basically whenever the transition state is called, it's going to set the state to whatever the reference is currently. And to continue our code breakdown, so we kind of have the abstract state class, and again it has kind of a method, or like it could be interface to that, just to set the state. So here we have our concrete state. So as we can see that they're overriding the method from the abstract class, and they're each kind of implementing their own specific behavior. So with the concrete state fall, as you can see where it has its behavior, so the season has not changed from fall to winter, and then we're setting the current state to the next season, and we're kind of doing that for all 4 of the concrete states, or all 4 of the seasons in this case. So these are the other 2 concrete states, and as you can see, it's very similar. Each are implementing their own specific behavior. So now I'm going to show a demo of how the code looks like overall, and like how it runs and what the output will be like. So this is kind of a demo of the code. So again, we already talked about this. We have the abstract state class, which just kind of provides an interface for the concrete states to implement. We have the context class. We have our concrete state classes, which, as we could see, they implement the method from they override the method from the abstract state class, and they each kind of provide their own specific behavior. And again, I guess for the context class, we could see that kind of saves a reference of the current state, and whenever we want to transition a state, it just sets the state to the current reference of whatever the current state is. So here's kind of the client code. So we have kind of an object of the context class, and we're passing in kind of the concrete state fall behavior first, because again, we want to start with the fall season. So our first transition, again, we're transitioning from the transition state method. So fall to winter is going to be our first transition, then winter to spring, spring to summer, summer back to fall, and then fall to winter. So if we run this code, 1 second. If we run this code, we can go ahead, we can see that it says, season is transitioning. So season has now changed from fall to winter. Season has now changed from winter to spring. Season has now changed from spring to summer. Season has now changed from summer back to fall, and finally fall back to winter. And so as we can see, the state is kind of transitioning through all the seasons. And that's kind of just a quick short demo of the state design pattern. So here I kind of want to use like an actual kind of like real world motivating scenario as well. So here we kind of have an application that updates a customer on an item they've purchased. So let's say we want to build an application that updates a customer about an item they purchased from the time it was purchased to the time it is delivered. So in this kind of scenario, the item purchased will go through a series of states. So we have the items purchased by customer, item is found in the warehouse, item is packaged, item is going to be like loaded into the truck, and then finally the item being delivered. And this is a visual of what the real world example would look like. So again, we have the context, the state, and we have our concrete states. We have 5 of them: the purchased state, the discovered state, packaged state, loaded state, and delivered state. And as we've said many times before, these concrete states, they're just implementing the interface from the state class, the abstract state class. So I'm not gonna kind of break down the code again as we did earlier, because I mean, it's going to be a similar structure. It's just kind of a more real-world-ish example, more real-world-ish scenario. But I'm still going to demo the code, and we could see how it works, as well as we could also later on see why the state design pattern is scalable and whatnot. So this is our code for demo 2. The packaging purchasing app is supposed to track the customer's item once they purchase it. So it's this really the same structure as the seasons demo that we did for the first one. We have the public abstract state class, which is is supposed to provide kind of interface for the concrete classes to implement. And then we have our context class, just saves the reference of the current state. The only difference here really is that we added an item name, so we will be prompting the user for an item that they would like to buy. And we have our concrete states. Again, they just kind of implement the abstract method from the state class. They override it, and then they kind of implement their own specific behaviors. So we have the purchase state, discovered state, package state, loaded state, and finally the delivered state. So here's our main code. We're going to prompt the user what they'd like to purchase. We're going to put their answer in the item, and then we're going to create an object for the context class. We're going to pass in the purchase state as well as the item, and then we're going to transition to the state. So we have purchased, discovered, packaged, loaded, and finally delivered. So let's kind of see the output of this code and see what happens. Smooth down. Give it a moment. Okay, so it's going to ask us what we'd like to purchase. Let's say we want to buy a laptop. So I'm going to say retrieving info on laptop. Laptop has been purchased. Retrieving info on laptop. Laptop has been found in the warehouse, so it's transitioned here. Laptop has been packaged, transitioned. Laptop has been loaded into the truck, another transition, and finally, laptop has been delivered. Okay, so that's pretty much the code for demo 2, but there's still kind of one thing I want to show is that later on, or after this demo, I'm going to be talking about the consequences of the state design pattern. And kind of one of the pros of the state design pattern is its scalability and how easy it is to kind of add new states. So that's one thing I want to showcase here, as well as how easy it is to add a new state. And the state we're going to add is the refund state. So if the user wants to refund, it's going to change the state to, your item has been refunded. And just for the sake of time, I already pre-wrote some code for this, just mostly just for the main here. You're just gonna prompt the user if they'd like to refund the item. If yes, it's gonna change the state. So we could quickly go ahead and just add a refund state here. And we could really just copy this from here. Change this. You really just copy paste from up there. Hold on, you forgot you have to copy paste not just the console right line. So there we go. We just copy paste that from here, and we could just say has been refunded. And yeah, so it's just that easy. We just added a new state without really changing anything from any of the other classes up here. So let's see kind of with our changes what the output is like now. So what we'd like to purchase, again, let's say laptop. So it's like, would you like to refund the laptop? Let's say yes. So as you can see, it changed into the state to your laptop has been refunded. So it changed the state one last time with our newly added state. And again, we did not really have to change anything. So that kind of shows how scalable, the state design pattern is. And that kind of concludes this demo. So let's look at some of the consequences of the state design pattern. So some pros include reduced coupling, and we achieve this kind of by encapsulation. So we are encapsulating behaviors of each state in separate classes. And this pro mostly also comes from the separation of concerns principle, which was one of the problems that the state pattern, strives to solve as well. So this low coupling also introduces good scalability. Adding a new concrete state does not require us to, recompile or change any existing code. All we do is just simply create a new, concrete subclass. The code simplicity comes from us, also encapsulating behaviors in separate classes. This makes the code easier to read as well as just simpler in general. Finally, we also remove the need for complex conditionals as we are using, the delegation to kind of figure out what the current behavior should be during runtime. Some cons include there being a possibility of a large amount of code, especially if we are dealing with kind of a large amount of behaviors. And this in turn can make our code more complex. But again, kind of due to the separation of concerns principle, overall the code should stay relatively simple. So now we're going to kind of take a look at some similar patterns, starting with the strategy design pattern. So to start off, they're both composition patterns. You know, a lot of these patterns tend to be composition based, but it's still something, you know, worth mentioning. So by composition, we mean that we are kind of delegating work to other objects. Furthermore, you know, these patterns are both behavioral patterns. So in other words, they deal with altering behaviors of objects during runtime, but the thing here is that they do differ in their implementation. And both of these patterns also follow an open-closed design principle, which means that they allow extension but do not allow modification. And this is relative to the code. So we can add new functionality, for instance, without the need to change existing code. And that kind of, like as we said earlier with the whole, you know, scalability thing. And you know, as we said earlier, these are both uh, behavior patterns, so they deal with behavior change based on context. So to look at the differences now, you know, some of the main differences is that strategy encapsulates an algorithm, while you know the state encapsulates state-dependent behavior. So when we say encapsulates an algorithm, we are saying it encapsulates how an object performs a task, or how an object will kind of, you know, I guess, alter its behavior. But with the state, we are encapsulating what state an object is in, or what state an object, you know, is going to be in. So also, with strategy, objects are dependent of each other. So in other words, they don't know of each other's existence completely. And with the state pattern, we don't have these kind of relational restrictions. So now moving on to the bridge pattern. So again, you know, composition, we're delegating work to other objects. The major similarity here is mostly just from the code structure being similar to that of the state, you know, and that we have like a class that provides interface for the client or acts as a client, while we have an abstract class that defines interface for concrete classes to implement. It's mostly just the code structure that is very similar, as well as some of the, like, UML diagrams could also look mostly the same. So although they, you know, have kind of this similar solution structure, or this structure in general, they do differ in the problems that they solve. So, you know, with the bridge pattern, you know, we're kind of, the main problem here is separating its abstraction from its implementation, while, you know, with the state, we're just mostly working on altering behavior, changing states during runtime. So also, you know, with the bridge pattern, we are kind of splitting closely related classes into two separate, you know, hierarchies. So like, for example, just kind of random example, you know, we could have one hierarchy of classes that have to do with shirts, and another hierarchy of classes that have to do with colors. And there, you know, there would have to be kind of a bridge and a way to make the two interfaces kind of work together, or the two like hierarchy of classes work together. Uh, so in a way, it's more so similar with kind of the adapter pattern, in that, you know, we're kind of adapting an interface to work with another. So here's a code snippet of the bridge implementation, the bridge pattern implementation, as well as the state pattern design pattern implementation. And this is mostly just to kind of touch up on the last slide about how similar these two are in their structure, and mostly in their code structure. So the main point here is that although these two patterns are so similar in code structure, what's interesting here is that they both solve two completely different uh, problems. They both have kind of, two different intents in a way. So these are the sources that I used to make this presentation and to get more, information on the state design pattern to learn what it is. As for the coding, it's completely my own. It's my own original code, as well as kind of the motivating examples are examples that I came up with on my own as well. I'm not sure if there's anything out there that's like kind of the season one as well as the packaging one, but they're all kind of my own original examples. And this concludes the presentation, my presentation on the state design pattern. Thank you for watching.